class I have completed the number concept, the different number concept. Till now I have completed so many concepts, and prior to that I have shown you different problem on surds. So I have explained around 50 numbers of sums on surd, and now it is a turn for the sums on number. Whatever I've taught, I will try to cover each uh, facts or each concepts with a numerical example so that it will be clear. So my request is that whenever you are following these numerical problems, try to just run through the theories or the concept that I have taught in my videos. So let's start with a simple problem. That is, the first problem is the you have to find the LCM. The LCM of 48, 108 and 280. These are the three numbers of which the LCM you have to calculate. So LCM, as I have explained, there are two methods. One is prime factorization method, LCM or HCF, whatever may be the case. So in both cases, the prime factorization okay, and the second one is division method. In this case, division is not actually a division. I have to divide the numbers with such number which would be a prime number to start with. Again, it is a prime number. Here concept is bit different, but in the case also, in this case also, I will calculate the cumulative. I will do the cumulative factorization, here individual factorization. How will I do that? Let's start with the first process. Okay, in the first process, if I take the factorization of 48 individually, so this will be come like this. So you can write 2 into 2 into 2 into 1, 2, 3, 4 into 2 into 3, 48. Okay, so 48 can be written like that. Okay, now come 108. I will do the factorization 2 because I have to start with the minimum prime number. The 2 is the minimum prime number, so I start with that. 2, 54, 27. Now 2 is not would be which can divide 27, so I will try the next prime number, that is 3. So it will come 9, 3, 3, and at the end this is 3. You need not to do it. So I can write this is 2 into 2 into 3 into 3 into 3. So this is your 108 going to 280, starting with 2 again, 140, 270, 235. Now you can see next prime 2 is cannot be divide this one, so next prime I will try 3. 3 also cannot divide, so next prime to that is 5. So 5 sevens are. So it is again a 5 prime number, so I will end up here. So we can write it. So this is the first step where I have to do the individual prime factorization of the numbers. Now the next thing is that when you are doing LCM, that means the lowest common multiplier. So in that case, you have to consider all the factors, because there are kind of factor is 2 is here, 3 is here, 5 is there. So these are the variation of prime numbers which would be a factor any of these numbers. So I have to take the maximum of the kind wherever is available. So you can see there is, if I take the 2 as a prime number, prime factor for these numbers, so 2 is coming highest here only. So the LCM will be calculated by taking the highest power of the prime that are coming commonly to any of this number. That means 2 is coming here, 2 is coming here, 2 is coming here, but there 2 to the power 4 means 4 2 is multiplied, there 2 here 3. So maximum of 2 I can get here, so I will get this one. So the 2 part is over. Now 3 maximum I am getting here, so I will take the maximum number of 3 wherever is available. Okay, don't confuse. Once the 2 being selected, I will select the maximum power and I will write it here for LCM, and I will forget that 2. Okay, once it is being selected, then after the next prime factor, that is 3, as a common it is coming in 2, but it is not coming here, but still I will take the maximum power of 3. Okay, now comes to the next prime factor, that is 5. 5 although is not coming here, but 5 is anyhow it is coming here. The maximum power of 5 is 1 and that of the 7 is 1. So these are to be taken all for LCM. You need not, you should not leave any of the factors, but only precaution you have to take, whenever I taking any factor, prime factor, you have to take the maximum power of that wherever it is available. Understood? For calculating LCM, you remember this term LCM. So our calculation would be 16 into 27 into 5 into 7. Now if I multiply it, better try to multiply where term will be easy. 5 16 80, and if I multiply to 7 560 multiply by 27, it will give 0 6 0 2 39 2 0 6 to the 12 11. So it is coming around 2 0 2 and 2 11 1 4 5 1. So this will be the result of these three numbers when I will calculate LCM. Okay, this is the first process where I will do prime factorization. In divisional method, I will do cumulative factorization. So that means all this three number will come in one bracket like that, and I will go on doing factorization simultaneously. So I will start with the minimum prime number 2. Here it will come 24. Here 54. You are 140. Till I will get 2 as a prime factor, I will try with the 2. Again 2, because any of this can be a factor of 2, so that leaving this as it is, I will go forward. Okay, I would not think if it is not dividing anything, so I will go on keeping it in same form. Now again 2 is cannot be done, or 2 is another way it will come, because there is one another, it is even number 3 27 35. Till now it is 2 is over. Now I will try with the 3 3 1 9 3. Anyhow it will not divide 35, so I will exhaust 3 till it comes to 35. Next I will do here 3 and 35. There is no common factor, so Yeah, the end number is 1 3 3 1 3 3 0, and another 3 will come because 1 3 35. So I will again can do until it comes to 1. Okay, you have to do that factorization till you get 1 at the bottom. So this will 35. Now it will again be divided with the next prime number, that is 7, then again 7 1 1 and 1 till I get all 1. I have to go on doing factorization. Now you see LCM will be the multiplication of all these three. Now you see the result. In initial first case, when I was doing the individual factorization, I got 2 to the power 4 for result. Here 3 3 3 to the power cube 1 5 1 7. So I am getting the same result here also. Okay, so the thing is that when you are doing division method, you have to go on doing, even if it is a single number being divided with any prime factor, till you get 1 at the bottom, till you have to do this factorization. So this is the divisional method of doing LCM. So in both cases you can see that number, the result is coming the same. Okay, now coming to the next problem. The next problem 2, it says there is a theory, but you need to know the product of two numbers is equal to what? So if you arise this is a standard answer for this. There is no different answer you will find. But this is a kind of theory, and you can use it for solving other sums together. So the product of two numbers, let's say A and B are two numbers, and their LCM and HCF, or that GCD, LCM or HCF or GCD be C and D. Let's say C and D, then we can write A into B is equal to C into D. This is one theorem that numerically with a trial and error or with the example you can prove it, and it is true for any number, any two numbers which are which can be computed where this numbers from which we can compute LCM or HCF, then this relation is true for any two numbers where the multiplication of two numbers is equal to the LCM and HCF of these two numbers. Okay. Next come the third question. It says the LCM of two numbers is 729, and one of them is a prime number, then the GCD or HCF of the number is dash. Okay. Now I read it, the question. The LCM of two numbers is 729 and one of them is prime number. Then you have to find the GCD. That means what is the GCD? That is given as dash. Okay. Now this is a very conceptual one. So let me explain it. So prior to that, if I do the factorization of 729, so let's do the prime factorization. So that will definitely be divided with 3, not by 2, because there is a last number 9. So 3 2 the 6, 3 4, 3 3, then 3 81, 3 27, 3 9 and 3 3. So how many 3's are coming? It is 3 to the power 6. Okay. So seeing this, the first step is over. So you can understand, then 729 is nothing but 3 upon 6, 3 to the power 6. Now, and one of them is a prime number. So if I get LCM this one, and one of the number is prime number, then what is the other number? So one thing I know, that LCM in the earlier question I have already said, into HCF is equal to the two numbers. Let's say the number are A and B, so A and B. So out of this LCM I know HCF has to be calculated. A is a prime number and what is B. So now if I get LCM like that, so and other number has to be a prime number, so that the possibility that other number must be that other number if has to be a prime, it must be equal to 3, because you see, if I do the LCM of these two numbers, that 3 to the power, now LCM I am getting 3. So what is the thing that can be done? 3, if you use one number I am saying is 3 the prime number. So with the 3 to the power 5, with 3 to the power 5, if I do it, or with 3 to the power 6, okay. So if one number LCM of the two numbers is this, and the one number of them is prime number, so if I take 3 as a prime number, then 3 to the with the 3 to the power 6, what will be the LCM coming? You see, 3 1 is 3 to the power 5. So you can see that LCM of these two numbers is 3 to the power 6 only. Okay. So now if I say that one number is 3, then only the other number, if it is 3 to the power 6, it will give you a prime number 3 to the power 6. If I take any other number, let's say for the cross check of this concept, if I take any number, let's say the prime number, one thing is that the prime number should not be a number which can be divided with any other number. So if I go any number further, means any number, let's say instead of 3, if I taking any prime number, let's say 2. So 2 with any other number cannot give you 3 power of something, because there is only one factor is coming, that is 3 and its power. So that there cannot be any combination of any other number apart from this prime number 3. So only thing is that 3 or 3's power can be the numbers, but only numbers that can be available as a prime number on 3 when 3 power is only 1. Any other power 2 or it will not be a prime number, it will not exist as a prime number. So only thing possible is 3. You get my point? My point is that if I take any other prime number, let's say 2, 5 or 7, it won't give you combination is such that where only one factor 3 will come, because I am taking other factors, so only one factor is coming for this number, for this LCM. So this is only possible when that will be combined with any factor, any other number which having only 3 as a factor. And if it is a prime number, so then only possibility is that it would be 3 to the power 1. So if that is the only one number, so other number must be this one. Okay, now once I got this number, the one number is prime factor 3, other number should be 3 to the power 6, then only their LCM is 3 to the power 6 I will get. So once it is being established, so I can calculate the HCF from this, because what is that? HCF is equal to, from here I can say that HCF is equal to what? A into B divided by LCM. So A is equal to the number 3 I say, B is equal to 3 to the power 6, and LCM is 3 to the power 6 again. So your LCM must be 3. Understood? Because it is the highest common factor. Between 3 and 3 to the 6, the highest common is 3. So your answer will be 3. So this is a very conceptual sum. So you have to understood this. And if I take any other example, similarly, instead of that, if I take any such number which is again a factor of only one prime factor, let's say if I take this one, so this is again a factor of 2 to the power how much? 2 to the power 10 I suppose. Okay, if it is the power of 2 to the power 10, then, and if it is the condition is same that the one is the prime number, then the other number must be 2 only. Any other combination of any prime number or any power of that will not give the LCM this one. Okay, so this could be a unique kind of sum that would be solved with this concept only. Okay, here probably you will get or you will definitely get only one factor. When if it is a other factor coming, then your thought process should be different. Okay, so thank you for now. In next class I will continue with more number of sums. Thank you.